Dash module number 2 then. Let's start off by powering it up in normal running mode. Now, when we power up in normal running mode, you'll see a number displayed briefly on this 4-digit display here. That just indicates the software version, the firmware version that's being run by the unit, so you can get an instant check of what software version is in. I think we have version 0.04 or 5 on right now, but let's power up and take a look. 0.05, so that's just the software version that flashed on for a moment. Now we have a speed signal. Let's just switch the speed signal off. You notice that beep. We need to say something about this. That's an option. You can choose to have that on or off. But with the speedometer, unlike any of the other modules, it has to store the odometer reading and the trip meter reading whenever you power down the unit. Now, it's not possible to do that when power is switched off, so we do it whenever the odometer reading has changed or the trip meter reading has changed. And the only time it'll ever change is if the car has been moving, so the speed has been non-zero, and then it goes to a 0 speed. The reason for this is that the odometer reading itself is stored while the unit is running in RAM memory, which is lost when the unit is depowered. To store in EEPROM memory, we can't do that continuously, so we have to only do it once every so often, and we do it when the car goes from a moving speed to a non-moving speed. Every time the car goes from a non-zero speed to a 0 speed, it will store the odometer and trip meter readings back into EEPROM, so that information is saved for the next power up. Okay, and when it does that, we give this short momentary beep, but that's just a diagnostic function that we use while developing the software. You can choose to have that on or off. So right now we have a 0 speed and we're indicating 146 miles, 146.1 on the trip meter. We can reset the trip meter. Let me see if I can remember which button it is. I think it's a long press on push button number 1. There we go, we've zeroed the trip meter. So there we have 146 miles stored. If we now put a speed signal on again and just clock up a bit more mileage, in fact, so that we can do that, we're only doing 44 miles per hour. Do you remember we talked about an overspeed indication on the speedo? I've got that set at the moment just at 65 miles per hour to test it out. So if I increase the speed so that it goes above 65 miles an hour, we should see it indicate an overspeed condition, and we'll get the speedo diagnostic LED flash and a warning tone. So here we go. Now the indication will continue to flash, but the tone will only sound once. And of course we can set that overspeed warning to any value we want. So we're now clocking up to a few miles. Look, 0.7 on the trip meter, and we've gone to 146 on the odometer. If the car now stops, so the road speed goes down to 0, you hear that beep, meaning that it's stored the value. So if I now depower and then repower the unit, we should see that those odometer and trip meter readings have been saved. They were saved when you heard that beep, when the speed went down to 0. So let's put the speed signal on again. Another thing that we have on here is the range, the sensitivity for the bar gauge. The default setting is so that an additional LED comes on for every increase in 10 miles per hour. So the scale would be fully on at 140 miles per hour. But if we have the high sensitivity switch on, we have the option of having twice the sensitivity. So an additional LED comes on for every 5 miles per hour. Just makes the display more colourful at low speeds. It's just an option. So we've talked about the odometer display, we've talked about the trip meter display, the speedo display, the odometer display, the trip meter display. Now, the odometer and the trip meter can operate either in miles or in kilometres, and the speedo, of course, in miles per hour or kilometres per hour. We indicate which mode we're in by this leading icon on the odometer here. Because these are 7 segments displays, it's not possible to display an M for miles or a K for kilometres. So we use a U to indicate miles and miles per hour as indicated by the units used in the US and the UK, and if we press this button to go into kilometres, then we indicate a C for Canadian units and also the units used just about everywhere else in the world. So they're the two unit options that we have for the speed: 72 kilometres per hour, odometer reading 4.3 kilometres, and a trip meter reading 4.4 kilometres, odometer reading 238 kilometres. Or back into our miles mode, speedometer is 45 miles per hour, odometer 2.9 miles now, and 149 miles. These two gauges that we spoke about before, do you remember we said they were the temperature, engine temperature, and fuel temperature? So let's just vary the inputs on the test rig. So temperature can go down or up, and if it goes to a certain level, we will indicate a fault or an over temperature condition on the temperature input. Once it goes above that temperature, the LED will continue to flash, but you only get the diagnostic sound once, unless the temperature goes back within range and then back out of range again, in which case you'll get the tone again. Fuel input, obviously there's no high level warning. We don't mind how much fuel we have, as long as it's not coming out the tank. But if it goes below a level where it's no longer reading on the gauge, then the fuel input will also indicate a fault. So we've spoken about the speedo, the odometer, the trip meter, the temperature and fuel gauges, the diagnostic indicator on the speedo. These three indicators here we said indicate left and right turn telltales, and this one indicates high beam telltale. We've got yellow on here because they're the colours that were used on the TV show, but some people find that they prefer to use a blue LED here to indicate high beam, which is conventional, and green to indicate the left and right turn signals. So you can fit those options if you wish. These, we talked about primary and secondary indicators. Those are three primary indicators. The other primary indicator, of course, is the fog light input. And the fog light input is one of these, which is not that one. It's that one. That's the fog light input. These are all high switched inputs, by the way. And then we spoke about these indicating ECM power, fuel pump relay drive, fuel pump relay output, and fuel pump fuse. So they're all high switch discrete inputs that we can use there. We did say that we can use this for different functions, and we do that by pressing push button number 1. So if I press it once, we have 7.3 gallons, so this is actually reading fuel now. So if I move the fuel input, in addition to the gauge moving, you'll see that the numeric moves as well. And that gauge can be switched between gallons and litres by push button number 2, so 10.4 gallons, that's US gallons. A long press on push button number 1 will change the units of the numeric displayed on that 4-digit display. So we're reading 41.6 litres or 10.4 gallons. Let's do a short press on here and we'll change to engine temperature. Currently reading about 204 degrees. A long press will put us into centigrade. About 94 centigrade, 95 centigrade, or about 200 Fahrenheit. Another press will read the voltage, the input voltage to the unit, which is currently reading about 10.3 volts. What else did we mention? We mentioned this indicator uses a voltage diagnostic. So if I just change the voltage You can see that when we get to about 14.9 volts, we indicate on this diagnostic that there's a fault with the power supply, over voltage. Bring the voltage down. You can see that when we go down to about 10 volts, we also get a warning, this time an under voltage warning. Obviously a 7-segment display won't display a V, so we've done a U in this position here, which is as close as we can get to it. Let's bring the voltage back into some healthy range again, and let's go into show mode, which we can do by long press on push button 2. So in show mode then, we have some random message which can be specified by the customer. Any scrolling message can be put in there of up to 256 characters. The numerics scroll through a range of speeds from 0 to 255 miles per hour and then back again. The bar gauges scroll up and down, and the speed at which they scroll up and down and the maximum and minimum values can be set using the user options. All these user options, by the way, they can be programmed by a graphical interface, and that's covered in a later video, or a later part of this video, where we'll see how we've got a graphical user interface that we can use to set all these user options and store them. The numeric 4-digit display is just scrolling through a number of values, up and down, and the diagnostic LEDs are coming on and off as well. So we can we can toggle between normal running mode and show mode just by a long press on push button number 2. Let's go ahead and switch back into normal running mode. And you should actually see that even though we've been in show mode, the miles have continued to clock up in the background. So even if you go into show mode while you're driving, you're still clocking up the miles. You still have the functional odometer. Let's depower the unit, and we'll take a quick look at the 2 diagnostic modes that we have on here, which are output test mode and input test mode. Let's apply power first. We'll go into the menu mode. We'll speak more about this menu mode and how to select the modes later. But in a similar way to we talked about on other units, if you power up in the menu mode, we have an indication of the 4 operating modes, which we can cycle around by pushing push button number 1. Normal mode, show mode, output test mode, or input test mode, and then back round again. So when we have output test mode indicated, let's go ahead and push button number 2, and we'll go into output test mode. Output test mode is going to test each segment of each display. So the 7-segment displays, each segment is being tested, and then they're being tested all together. So segments A, B, C, D, E, F, G point, A, B, C, D, E, F, G point, A, B, C, D, E, F, G point, A, B, C, D, E, F, G point all. So that checks that every segment of every display works. Let's check that every segment of each bar gauge works. And then the telltale LEDs. Each segment of the MPH indicator is working. The diagnostic LEDs, the red-green indicators, the bar, the whole display, and then a brightness variation on the numerics and the bar gauges. Brightness variation on the LED light bars. And then the audio tone generator. and then back round again. Same pattern will repeat until you power the unit down. So let's go ahead and power the unit down. Finally, input test mode. Let's apply power again and go via the mode menu, pressing push button number 1 to select input test mode, and then push button number 2 to go to that selected mode. Now the numeric display is just counting pulses. So if I change the speed at which the pulses go in, you'll see that it just counts pulses up to a value of 255 and then resets to 0 again. So this just checks if pulses are actually being recognised by the unit. If I switch the speed signal off, that will freeze. On, it'll count. These other displays represent the hexadecimal value of each of the analog inputs. These two here represent the hexadecimal value of the potentiometer inputs. Now we don't actually have potentiometer inputs hooked up to this module. That's why they're reading FF, which means maximum. Those potentiometers are used to determine the brightness of the display. Potentiometer number 1 determines the brightness of the numerics and these 20 element bar gauges. Potentiometer number 2 determines the brightness of the LED light bar components. And as I've said, if those potentiometers are not connected, it assumes maximum brightness and it sees an FF on the hex input. These other inputs here represent the other analog inputs. The first one represents the fuel. So if I move the fuel potentiometer right down, it'll go down to 0. If I move it right up, it'll go to about AA. If I move the temperature signal, that'll go between about E7 and 0. And that final one is the supply voltage. With an input of 10 volts, we're reading about AC or AD. At an input of 15 volts, we're just about off scale. So they're the raw values that are being seen by the unit. Actually, these bar gauges here as well, in input test mode, they also show a bar indication of the two potentiometer positions. And because they're not connected, they're showing off scale. In input test mode, this diagnostic LED represents the state of the latching switch. This one represents the state of push button number 1. This one, push button number 2. These red-green indicator pairs have the same function as they do in normal running mode. So that's the input test. Oh yes, and these also have the same function that they do in normal running mode. Left turn, right turn, and high beam. We actually have some spare inputs as well, which we're going to put as, which we're going to indicate the state of them on the bar. And those can be custom configured to have functions specific to any customer's request. So there we go. That's the 4 operating modes of Dash module number 2.